Hi, my name is Umair Durrani, and I am a PhD student at University of Windsor, Ontario, Canada. In this video, I'm going to share with you the high-level overview of the research that I have conducted with my colleague Dwanisha and my supervisor Dr. Chrisley. So let's jump into it. In a typical perception reaction time study, the PRT clock starts whenever the lead vehicle brake lights turn on, and it stops when the following driver starts to apply brakes. In these studies and in car following models, PRT is assumed to be a driver-specific fixed value. However, studies have shown that PRT varies with spacing, lead vehicle's deceleration rate and brake lights, and the type of lead and following vehicles. Defining PRT start and stop is harder in other car following states, for example, approaching state. For instance, when a car approaches a large truck from a large spacing, driver initially tries to maintain the current speed, the desired speed, but at some point in time notices that the lead vehicle is slow and slows down him or herself by partially or completely releasing the accelerator, and then later tries to maintain the current speed, a zero speed difference, with the lead vehicle. In this scenario, the first question is what made the driver slow down, the following driver? And because the lead vehicle brake lights were turned off, because the lead vehicle was not decelerating, how do we determine the start and end time of perception reaction time? Visual variables could help us in this regard. Visual variables determine how drivers perceive and react to something. Visual variables include visual angle, which is a function of width and the spacing to the lead vehicle, the rate of change of visual angle, also called as angular velocity, and tau inverse, which is a function of both angular velocity and visual angle. Now assume for a moment that you are the driver of that red car following the large truck in front of you and approaching it from a large spacing. Pay attention to the accelerator pedal position and how the tau inverse increases over time. As you get closer to the lead vehicle, the visual variable tau inverse starts to grow as well. There are two different approaches that define how we determine the point where the driver perceives that the lead vehicle is slow. The first approach assumes that the instantaneous tau inverse, when it exceeds a certain threshold, that is the point when driver perceives that the lead vehicle is slow. Another approach, which is quite recent and provided by Marcola et al., assumes that it is not a single value of the visual variable that driver uses to perceive the lead vehicle, that the lead vehicle is slow, but rather the driver accumulates the visual variable, for example tau inverse, over time, and then when the accumulated tau inverse exceeds a certain threshold, then the driver starts to react by either applying brakes or releasing the accelerator. We set out to find the difference between these two approaches and determine which one actually works for the driver. To determine the mechanism of driver's perception and reaction at different spacing, speed difference, and type of the lead vehicle based on the visual variable. In this particular case, we use tau inverse as the visual variable. For data collection, we divided a driving simulator study into two different scenarios. In the first two scenarios, we had reaction scenarios where we made the drivers drive at their desired speed, starting from the zero speed and accelerating to reach their desired speed. And then they continued on until they had to apply brakes because the lead vehicle also applied brakes. At some point in time, they had to slow down while approaching the lead vehicle. The scenario S2 was similar to the scenario S1. This was also a reaction scenario, and in this case, there were two main differences. First, the spacing was larger than in the scenario S1. It was 1200 meters, and the lead vehicle was completely stopped throughout the journey. For scenario S3, please see the poster. For scenario S4, we determined the perception of the driver while approaching the lead vehicle from a large spacing. and in this case that spacing was 1 kilometer. The driver accelerated to a speed of 100 kilometers per hour, and then the cruise control maintained that speed. The driver did not change the speed until the driver noticed that the lead vehicle was slow. We asked the drivers to slow down whenever they felt that the lead vehicle was slower than them. Based on these four scenarios, we developed three hypotheses for perception reaction time. The first hypothesis assumes that perception and reaction occur at the same threshold, at the same value of tau inverse or angular velocity. This approach is also used by the Wiedemann car following model to determine driver reaction. In the second hypothesis, we assumed the driver had a time difference between the perception threshold and the point when the reaction occurs. This time difference was either because of a driver-specific reaction time or a driver-specific reaction threshold. In the third hypothesis, we assumed that drivers do not use a specific value of threshold to react to a certain car following state, but rather a driver accumulate the tau inverse or angular velocity over time and then respond whenever that accumulated value of the visual variable exceeds a certain threshold. And here's what we found. We plotted the distributions of tau inverse when the driver released the accelerator, indicating the driver has noticed the slow lead vehicle in the three different scenarios. We plotted it for perception and the two reaction scenarios, reaction to the moving lead vehicle as well as the reaction to the stopped lead vehicle. And as you see on the slide, there was a significant difference between these three distributions. Considering the variation among different drivers, we found that overall that there was a higher value of tau inverse at which the driver released the accelerator in the two reaction scenarios compared to the perception scenario. And this held true for the lead truck case as well. Therefore, we rejected hypothesis H1 that suggested that drivers perceive and react at the same value of the perception threshold. We also plotted the perception reaction time distribution to determine whether the distributions were similar in the different scenarios, and we found that was not the case. We found that in the stopped lead vehicle scenario, where the lead vehicle brake light was off throughout, as well as in the decelerating lead vehicle scenario, which was the last part in the reaction to moving lead vehicle scenario, where the lead vehicle brake light was off. In both lead vehicle brake light off cases, in both scenarios, we found that there was significant difference in the distributions of perception reaction time. Therefore, we rejected the hypothesis H2 that suggested that PRD varied significantly between the two reaction scenarios. If the PRT was a driver-specific property, then the distributions should also be similar in two different scenarios. Instead, we found that the evidence accumulation concept could very well explain the findings in this study. Therefore, we plotted the growth in tau inverse, the visual variable that we assumed the driver was using to respond to the lead vehicle. We plotted the growth of that in the three different scenarios: perception and approaching, reaction to the moving lead vehicle scenario, and the reaction to the stopped lead vehicle scenario. And we found that the areas under the curve were mostly similar for a given driver, which indicated that the evidence accumulated, the threshold of the evidence accumulation was similar for a given driver. And this held true for the lead truck scenario as well as for other drivers. Therefore, we accepted the hypothesis H3 that suggested that drivers use the accumulation of evidence, in this case tau inverse, over time to reach to a specific threshold and then release the accelerator pedal or push the brake pedal. In conclusion, we found that drivers neither reacted after a driver-specific perception reaction time nor reacted at a specific threshold of tau inverse, but instead they reacted after the accumulation of evidence reached a specific value. Thank you. And if you want to contact us, you can contact at this email address or at my Twitter.